This lesson is dot product. Dot product is to find the relationship of two vectors. Okay, so one more time, dot product is the relationship between two vectors. So here we have a vector v, vector w, and we're going to use the dot product. And dot product is really easy. So all you have to do is just multiply them and then add them. So what you do is 1i plus 1i times the other 1. So here's 1, okay, times 1. So here's 1 times 1. So that's where I got the 1 from. Make sure it is I with I, okay? So make sure again it is the same variable that you're multiplying. So I times the other I, but we're just going to ignore the letter. We'll just focus on the number. So 1 times 1. So that's where 1 times 1. Okay, just ignore the letter, but make sure that they go together. I with I, J with J. One more time, when you do the dot product, I with I, J with J. And just ignore the variable. Focus on the coefficient. So 1 times 1. There's the 1, 1. Always by a plus. -1 times +1. There it is. Okay, so one more time. When you do the dot product, make sure I with I, J with J. Okay, now focus on the coefficient. 1 times 1, right there. Always by plus, -1 times +1, right there. Okay, so this is a basic order of operation. 1 times 1 is 1, -1 times 1 is -1. Subtract or add, 0. So this is the answer that we're looking for when you do the dot product of two vectors. Okay, so again, what is dot product? Is to find the relationship between two vectors. Okay, so the relationship of these two vectors is 0. Okay, now we want to find the angle of the two vectors. Okay, the angle between the two vectors. I'm using the same vector again, the same example that I just did. So I'm using these two vectors again, the same vectors. Okay, so first thing we need to do is find the dot product, which we already found out from here. That's the first thing we need to do. Find the dot product of these two vectors, which we already found out, which is 0. Okay, so again, where did I get the 0? From this example up here. Okay, again, it is the same vectors. Next, we need to find the magnitude for v, magnitude for w. So 1 squared plus -1 squared. So that just gives me 1 plus 1 square root 2. Same thing, find the magnitude of w, the vector w. So 1 squared is still give me radical 2. Okay, so this is the formula to find the angle between these two vectors. So v dot w, and then the magnitude of v times the magnitude of w. Okay, so be very careful in this formula. Be very careful of this formula. The first dot right here, this dot right here, is for this dot product. Okay, this dot right here is for the dot product. This dot right here is just regular multiply. One more time. The dot on top is for the dot product. The dot in the bottom, that's just regular multiply. Okay, so be very careful. So v dot product of w. Okay, so v dot product of w, 0. Where did I get the 0? Up here. Okay, and then the magnitude of v, the magnitude of w, square root 2, square root 2. The bottom dot is just a regular multiply. Okay, so square root 2 times square root 2 gives me square root 4. Square root 4, which just gives me 2. So 0 over 2 is just 0. Now inverse cos of 0, which is 90 degrees. So the angle between these two vectors, okay, the angle between v and w is 90 degrees. Okay, so here's the graph. here's V, okay? So here's V. V would be facing from 0, from the origin, going down that way. W also from 0 going up. The angle between these two is 90 degrees, okay? All right, so that's what it looks like, and I hope the graph will help you to visualize and understand much better, okay? And be very careful of this formula. The first dot on top is for the dot product. The dot in the bottom is just regular multiply, okay? So again, the purpose of dot product is to find the relationship between two vectors, okay? So let me zoom out so that you can see the entire example of this page, the first page, okay? All right, so let's do the second page. Now we want to know, is it perpendicular or parallel? We want to know, does these two vectors perpendicular or parallel? Now, another word for perpendicular is orthogonal. Okay, another word for perpendicular is orthogonal. Okay, so is these two vectors orthogonal or parallel? Okay, so I'm using the same example from the first page. Okay, if you can see this, here's V. It is the same vector. Same thing with for W. I'm using the same vectors again. Okay. All right. So how do I know that these two vectors are perpendicular or parallel? So using the dot product. So same thing when you do the dot product. I with I, J with J. But ignore the variable. Just focus on the coefficient. 1 times 1. Right there. Always by a plus. -1 times +1, which is right here. And basic algebra, so that gives me 1 minus 1, which gives me 0. So when you do your dot product and it comes out to be 0, then these two vectors are perpendicular. One more time. When you do the dot product and it comes out to be 0, then these two vectors are perpendicular, or fancy way of saying it, orthogonal. Okay, so one more time. When you do the dot product of these two vectors and the answer comes out to be 0, then these two vectors are orthogonal. Okay, so note to be orthogonal. Okay, to be orthogonal, the dot product must be 0. Okay, one more time. To be orthogonal, the dot product must be 0, or the degree comes out to be 90 degrees. Okay, one more time. To be orthogonal, the dot product must be 0, or you can do the angle and get 90 degrees. Okay, to be parallel, the angle must be 0 degree, or the first vector is equal to a half of the second vector. Okay, one more time. To be perpendicular, the dot product must be 0, or find the angle, which is 90 degree. That's what we did earlier. Okay, to be parallel, the angle must be 0 degrees. Okay, 0 degree, or the first vector is equal a half to the second vector. Okay, so that's how you know, is it perpendicular or parallel. Okay, so let me zoom out this second page so you can see the entire part, the whole example of second page. All right, and the last page, we want to find the decomposition of a vector in two orthogonal vector. Okay, so decomposition of a vector into two orthogonal vectors. Okay, so what we want to find out is, given an example, we want to find one vector is parallel to W. So here's W. We want to find a vector that is parallel to W and orthogonal to W. Okay, so decomposition means we want to find two more vectors. One of them is parallel to W and the other is perpendicular to W. One more time. Decomposition means we want to find two other vectors. One of them is parallel to W and the other is perpendicular to W. Okay, so first thing we need to do is to find the first vector that is parallel to W, to find the first vector that is parallel to W. So here's the formula: V dot product of W all over the magnitude of W squared times W. Okay, so here's the formula. So first thing we need to do is find the dot product V and W. So 1 times 1, there's 1 times 1, always by plus. 3 times 1, there it is. Okay, again, when you do the dot product, make sure I with I, J with J. Now focus on the coefficient. 1 times 1 here. Okay, 3 times 1 here. Okay, so 1 times 1 is 1. 3 times 1 is 3. 1 plus 3 gives me 4. There's the 4. Now find the magnitude of W. So 1 squared, 1 squared. So 1 squared is 1, 1 squared is 1, which gives me 2. 1 plus 1 gives me 2, square root 2. However, I have a square outside. I have a square outside right here with a square outside. So this square and this square root cancels out. This square and this square root cancels out. So that just leaves me 2. So reduce 4 over 2 just gives me 2W. Don't forget this extra W. We always forget this extra W. Okay, so bring that W along. Well, what is W? I plus J. Okay, so I plus J, so multiply it out. So 2I plus 2J. So this first vector right here, this first vector is parallel to W. Okay, so one more time. This vector right here is parallel to W. Now we want to find the other vector that is orthogonal to W. Okay, so here it is. Now to get the second vector, all you have to do is take the original vector of V, subtract from the V1. Take the original vector and then subtract it from the vector that we just found out. Take the original vector, okay, take the original vector, subtract from the vector we just found out, okay? So here's the original vector minus the vector V1 is the one we just found out. And then just subtract them, okay? So, so all you have to do is make sure, be very careful, I with I, J with J, okay? So I minus 2I, okay? I, don't forget the negative, I minus 2I, that's right here, okay? And then 3J minus 2J, that's here. So I subtract 2, get 1 subtract 2 gives me negative 1, 3 subtract 2 gives me 1J, okay? So negative I plus J. So this is the vector, the second vector that we are looking for, which is perpendicular to W. Okay, so this is the second vector that's perpendicular to W. Okay, so let me go back. Let me give you a graph so that you can see, and hopefully the graph helps you to understand better. So here's V1. Okay, V1 is right here, right there. The original vector. The original vector is right here. Okay, W is right here. Okay, now V1, that's what we just found out, is in the same direction and parallel to W. V1 is in the same direction and parallel to W. Okay, all right, and then V2 is perpendicular to W. Okay, so one more time. Here's V, there's V, W, W. V sub 1 is the vector right here where I'm circling. This vector is in the same direction and parallel to W. Okay, same direction and parallel to W. V2, right here where I am circling, is perpendicular to W. Okay, so I hope the graph help you to understand a little bit better. Okay, so let me zoom out so you can see the entire example of this.